Hey everyone, and welcome to the channel. Today we're diving into the world of mechanical design with a powerful component, the Schmidt coupling. Ever encountered a situation where you need to connect two shafts that aren't perfectly aligned? The Schmidt coupling comes to the rescue, allowing for smooth torque transmission despite misalignment. In this video, we'll be exploring the inner workings of a Schmidt coupling. We'll break down its key components, delve into its clever mechanism, and understand how it tackles misalignment challenges. We will just need 5 individual parts. There is the hub, then the shaft, then an inner disc, an outer disc, and the link. Alright, let's start modeling. I will start in an empty part studio. Take the sketch command, place my sketch on the front plane, press N, normal view to that, P, hide all planes, L for my first line, and dimension that with 56. Then take that slot command here, pick that line, and give that a dimension of 24 millimeters here. Change that to construction geometry, pressing Q. And then I'll just take the 2-point rectangle tool, press Shift M for the midpoint constraint, take that point and that line, then press T for a tangent relationship here, make that construction geometry, press D and dimension that with 44, and then C for a circle from here, give that at a dimension of 18. And that's it for our first sketch. I'll go into the extrude, take that region, give that a dimension of 22 with a symmetric condition, make that sketch visible again. Again, extrude that part, symmetric as well, and 12 millimeters. I'll apply chamfer to those lines here and call that part hub and change the appearance to some light gray here. Go back to the extrude, take that circle, make that a new body, symmetric offset, and give that 44 dimension. Name that shaft and change the appearance to some light blue here. No? That one. Okay. I can hide that sketch. I continue with the next sketch on this face here. With U, I project that edge. With L, I draw a vertical line with a 48 dimension. Then I go into the circle command and place a circle here, 22 millimeters diameter, and make that construction geometry, make another line here, that is equal to that one. Again, construction, geometry, and at an angle of 120 degrees. Place one more circle here. Make that equal to that one. And again, construction, geometry, then a 3-point arc. Connect that here. With T, I establish the tangency and give that a dimension of 44. And then let's make a circular pattern within the sketch environment. First, I'll make one more circle here, and that is 12 millimeter diameter. So now the circular pattern of those 3 sketch entities, and there's a preview, but I want the origin of that pattern right here on that vertex. I accept that, and that's it for that sketch. I exit. I go into the extrude, take that sketch region, add those here, and give that a symmetric 6 millimeter dimension. And make that sketch visible again. Shift E, and add those regions symmetric with 22. Adding. And okay, when I executed that extrude, I edit, but I want a new body here. So I need to fix that extrusion as well. This is adding not to the shaft, but to that disc. And I'll call that inner disc. And give that different appearance here. Okay, so we got these 3 parts now. And now from that inner disk, I will make a copy. I go to transform, go to copy part, go to translate by values. I take that part and just pull it out. Doesn't matter the distance. First I'll rename that outer disk and change the appearance to that. Maybe that one. And now for that outer disk, we don't need that symmetric offset. So I'll just delete those here. And one convenient way to do that is I go to delete face with the heal option. Take that part, just pick on those faces. And okay, that fixes that. We just need one more part. I go to the sketch, pick that face, press N, press U, take that inner circle, then draw a line over there with dimension 62. Give that a horizontal constraint. Go to the slot. Open that here, yeah. Delete that. And make a coincident relationship between that circle and that point here. Okay. Then make this line construction geometry. Draw one circle here. Make that equal to that one. And, well, exit that sketch. Go to Extrude. Take that face, that region, and extrude up to that face. Now this time a new extrude. Okay. Rename that link. Change the appearance to some red color here. And, well, I'll just give it a shell. Take that face, take the other one, give the shell thickness 4 millimeters. There it is. And that is all we have to model really for this design. I'll hide the sketch 2 here. And enter. Go to the Assembly tab, go to Insert, and take that hub, and take one shaft. So let's define a relationship between those two with a revolute mate. Pick that central mate connector, and here as well, if you have trouble picking that, you can press the Shift key, and then you can select the one you want. Okay. So let's just now fix that in space. I'll just take the fastened mate. Take that bottom vertex or position, take that origin, there it is. So that is the driving shaft, let's call it like that. And now let's create that situation of misalignment. So once again, I go to Insert, take one hub, and one shaft. Let's create that revolute mate between that position and that one. And now let's define that offset here. So let's say we want this shaft to be some distance, the z-axis, misaligned. Take the planar mate, take a position on that face with the z-axis going upwards. Another one over here. Then go to offset and give that a -96 value. All right, there it is. Now let's say we want to offset that to the right some distance. I take the planar mate again, take that point, take that one, go to offset, go to -48, accept that. Let's have a look. Okay, so we changed the Z position in relation to that coordination system, then the X position, and now we just need to Now fix the Y position. So I go to offset or the planar, take that face, take that face, go to -66. Accept that. And there we have the situation. So let's insert the other parts to fix that. I go to insert, take that inner disk, place that there, that outer disk, and the link. So let's start with the outer disk and the driving shaft with a fastened mate. So I take that edge and that one, and then the revolute between that edge and that one. I can move that out of the way. Let's insert some more links here. I take that and insert that 2 more times. Go to revolute, take that edge and that one, and that one, and this one. No, this one and that one. Yeah. Now let's connect that inner disk again with a revolute mate. Take that and that one. And okay, let's move that a little. And again, that one, this one. I'll move that link. And one more here. And there. All right. This is turning. Let's insert one more outer disk, or copy this one. I double click to turn that around. Take that fastened mate, that edge, and that one. And copy some more of those here. And now let's connect those. So again, the revolute mate here, here, and there. Now take that edge and this one. Before the next revolute, let's make a temporary fix of that disk, ignoring the error warning, because we just want to rotate to get that to position, those two here. Okay, and then just unfix those. Now let's make this revolute here. All right, and finally this one with that one. And that's it for mating. So that is our design from the front. The driving shaft, the driven shaft, and the Schmidt coupling. And now let's take that driving shaft that Revolute made, that initial one between the shaft and the hub. Go to animate, make that a loop, and play. And there it is. The Schmidt coupling, modeled, assembled, and animated in Onshape.